line. So let me say this again now. So R is how well the points would line up on a line that best fits them. If I have 2 points, the line that best fits them is going to go through both of them. So what would R be? 1. I love it. I love it. Beautiful. So that's a nifty question because you have to really understand what R means. You have to understand that if I have 2 points, it makes one line. There's only one option. If I have a third point, it could be off, and then my R might not be 1 unless it lines up perfectly with the other 2. All right, I like it. So watch this stuff here. Well, anybody need to borrow a calculator? Let's do that right now. You're going to need your calculator today for sure. Don't think somebody else's.
I thought everybody has one. Is there a
Hold on. Yeah, hold on. Just a second. There's a new one of these. And you got the stuff from last time, right? You got this?
Oh, yeah.
Yeah. There's no new worksheets in it. Yeah. Now we're doing extraneous stuff that I do sometimes. Yes?
So the closest that our car is to the trouble before.
Oh, yes, exactly. Now we understand that strength of correlation means the points, how close they are to the line that goes through them, that best fits them. So that line is like a graphical average, right? So the closer the points are to that line, the stronger the correlation, the closer to 1 or -1 it's going to be. With me? So you could think about the absolute value of R, because the negative just means it's got a negative slope. So if R of 0.9 and R of -0.9 indicates the same level of strength. One's for a positive, the slope, and the other one's for a negative. I like it. All right. So now watch this. If I put it to my list, if you go to Stat, Edit, and I'm just going to put 2 points in here. In fact, let's put these points. Yes?
Sorry, going back to the correlation from that. And if it's closest to -1, then it's a strong negative correlation.
Yes, totally. Yes. So, if the absolute value of R is close to 1, it is stronger and stronger. It's closer to 1. The negative and the positive really just relate to is it an upward trend or a downward? Yeah. So the relative size of R, how far away from 0 it is, tells you how strong the correlation is. You guys cool with that? So that's beautiful. I want a freaking number. If this is all about, I have data, does the data seem to line up in a certain way? If the answer is yes, the next important question is, well, how well do they line up? Do they kind of sort of line up and I'm not going to use that line for shit? Or do they really line up pretty well and I'm going to use that line to make predictions about some other data point? The number I get for R that helps me determine if it's good enough or not. Okay, maybe. So we clear all this out so we don't have all this weird shit with me. So let's put these in, 0 and 32. So the point 0, 32. Some of you guys might know where I'm going with this. Especially if I put this in 100 and 212. So I have 2 points there, the point 0, 32 and the point 100, 212. Does everybody know what this might relate to, these numbers? Say again? That's right, but that would have been true about any numbers, right? If I would have put 5, 7, that would have been X and Y coordinates. These numbers specifically, does anybody see what they might relate to? No, okay. 32 and 0, 32 degrees is where what happens? Water freezes, at least for Fahrenheit, which we're basically the last country on Earth to use that. The Celsius scale is, of course, more related to metric. It's 0 for freezing water at a certain pressure and all that kind of crap, and 100 for boiling water. I like it. You guys semi with me? Do you guys remember at all, even if you don't remember the specifics, but you remember there was a formula for converting between Celsius and Fahrenheit? I like it. So we're basically going to make the calculator spit that thing out to us. So if I go stat, where do I go to get this linear regression? Where do we go to get the line of best fit and the R? Yeah, the fourth one down. So go to stat, calc, fourth one down. L1, L2, make sure that's in there. If you have the old style calculator where it just says lin reg, just hit enter because it defaults to L1 and L2. So let's see what this thing tells me. So I'm doing this for two reasons. This is a very quick way right now to figure out if anybody has a calculator that doesn't show R. Okay, all right, so do this. You ready? And anybody else who doesn't want to tell me, it's okay. Not everybody's going to show R. Do this. Hit second 0. It should show this up on the screen. And then hit this button with the D. The X to the -1, bam. So I'm going to go to the D part of the list. Is that cool? And then go down to diagnostic line. Enter. Enter. That's exciting. Huh? And now you go back to stat, calc, number 4, blah, blah, blah. Now you should have R shown. Okay, okay. You good? I like it. I like it. All right. So that's what we predicted, right? R is 1. I've only got 2 points. So, of course, the line that best fits those points is going to go through both of them. 2 points to find a line. So, of course, R is going to be 1. 1.8, well, that makes sense because I don't know. Does anybody remember the conversion between Celsius and Fahrenheit? You know, your math board, you probably get that thing memorized.
If Fahrenheit equals Celsius minus 32, minus 32 5 is 5 over 9.
Yeah, the other way around, Celsius would be 5 nines Fahrenheit. Yeah, Fahrenheit's 9/5 Celsius. What's 9 divided by 5? And here's a quick way to divide by 5. Double 9, you get 18, because then you would get 10 on the bottom. Move the decimal back 1, so 1.8. So up there, look, the slope is 1.8. The y-intercept is 32, in this case, the f-intercept. You guys semi with me? So any problem in algebra where they ask you to find the equation line that goes through these 2 points, you could have done it right there. Ha! Sorry. But of course, now that you know that shit, I can show you the shortcut. This calculator's not trying to pass algebra. You were. All right, so let's do a real problem and make sure everybody's got the steps. And then I'm going to give you guys this one sheet to practice with. I'm kind of excited. I updated the data on this and I haven't really done it yet. So I'm curious to see how it comes out. So let's see, let's just make up some data. Let's go into my list. Everybody get into your list. Let me see if we can figure this out. So we just put in there, in L1, let's put 1, 2, 3, 4, 5. Okay, so let's see if you guys can help me out. So if I put like 20 here, see if you guys can really piece this together. And I want R to come out negative. I want R to come out negative. Do I start putting numbers that are bigger than 20 or smaller than 20? Yes, of course, right? Because I want as my x's go up, I want my y's to go down. That's when R would be negative. That's a negative relationship. One going up makes the other ones go down, like number of beers versus grade the next day. I like it. This is an averaging. I love it when somebody's like, my friend Tom can drink like, oh my God, and maybe age that. Shut up. I'm talking about average for everybody drinking the beer. You're going to have these outliers all the time. So I could put in there, let's say like 15, 11, 6, and let's do 5. So you might not have the best feel for this yet, but do you think R is going to be decently strong for this set of data that we created? It should be relatively okay. I don't know. I would predict negative 0.7. And then we'll do it and you'll see how far off I am. So you know, it's hard to have a really good feel for this. But let's see. So how do I, again, to analyze this, how do I make the scatter plot show up? Let's do that. How do I make sure the scatter plot's going to show up? Where do I have to go? Where do I go to graph anything? I like it, but how do you put stuff in for it to graph? That's what you do after you've got the data in and set up. But I go to stat plot. Let's all go to stat plot. Make sure this sucker's turned on. Because we've got some newbies here today. You guys with me? Make sure only number 1 is turned on. And make sure you got the little scatter plot selected. How we doing? Yeah. Stat plot right there. Second wipers. Go into plot 1, make sure it's turned on, make sure you've got scatter plot selected. L1, L2, you can pick which symbol you want to put on your data. Okay, I definitely always pick the square. Yes?
Just a really basic question. Is A equal M?
Question. Yes, I love it. Yeah, it's sort of like just ask people like, we can't use M, that's for math people. Let's use M. Whatever. Okay. And then, now if I hit graph right now, it's going to be shit, but it's not zoom 6. It's zoom what? 9 for zoom stat. So most of you guys, it should be 9. Some of you guys, the menu might be offset because some of you might have added more shit to your copy. I don't know. But it should be zoom 9, and then you should end up with this. That looks really strong, my God. It's a very small sample, but it's really lined up pretty well. We kind of designed it, so hey, with that. So now how do I calculate that number that tells me how strong this is? And I predicted it's going to be, now looking at this, probably might be better than negative 0.7. How do I calculate that? And calculate the line that goes through the data the best. Go to stat, calc. Number 4. I love that number 8 exists. I really do. Just in case you're like, no, I always wanted B to be this. Screw it. So number 4. Yeah, that's really good. To make the point out of it. So that's really strong, but we designed it to be pretty strong. It was pretty lockstep. It's not -1 because then it wasn't a perfect slope. For every 1 I went up on the x, I didn't always go down 5. So it's not a perfectly straight line. How do I get that line to show up on the screen? Where do I go to? Y equals. That makes sense. We'll put that line in. So let's see. Somebody help me out. Write this down. Negative 3.9 slope. 23.1 y-intercept. Let's see if I can remember that. Negative 3.9 slope, right? Or was it 0.3? Not sure. I'm already...
Negative 3.9.
Good. Plus... I definitely forgot that. 2.3. 23.1? Okay. Alright. So we see where the X button is. I always get somebody to freak out. They don't put the X in there, they get this flat line, of course, because then it's a constant. Big graph. Bam. So do you notice how, and again, I know, because this one was a little up, do you see how it raised, it kind of tilted the line around? So it's almost too beautiful. If I have a number in a list of data that's bigger, it's going to pull the average towards it. This is a 2D version of that. It's like a little mass gravity pulling the line towards it. It's way too nifty for, and it actually isn't, I know, I understand, but it is sort of nifty. So you can kind of see the effect that outliers have on the average, because the average is now one-dimensional thing, not just a point, not just a number. It's this line. I can actually see it moving. All right, I like it.
What did you
This here. Yeah, so the AX plus B. I like it. So, I want you guys, I just updated this morning. I didn't put, I'll tell you what California was. I didn't put California here because California ends up being the most extreme outlier. And I wanted our stuff to come out pretty decent here. So. Definitely. Because otherwise we would all die. Exactly.
Of course. Outliers will put more income in that distribution.
So guys, so there is a side one. Do that side. The other side won't make any damn sense at the moment. So you can kind of look at it and go, M&M's, neat. Did you bring any? No. The bastard.
Goodness of the.
Don't worry about that yet. Just side one.
Sounds like a publisher's stuff.
I know. It's not my name. I know it sounds like a name I would have made up.